So today I'm going to talk about the OpenStack and OpenDaylight integration, specifically for the service function chaining. I think the session that Andre and Brady was giving, they were talking a lot about the detail of that part and how we are doing it and how we are solving these complex problems from the ODL side of it. Now, what I'm going to show you guys is like when you talk about these big words, OpenStack, OpenDaylight, and SFC, these are pretty complex systems. Okay, and anything you want to talk within 25 minutes is a bit of risky job. So I try to explain this as simple as possible. What I wanted to you to take away from this session is what work was already there and where we are heading towards and what kind of work we already did. So and at the end of the session, I'll show you a demo, which actually the current work which we are doing and which we did. I think I'll show you that demo, that how we are actually making the whole integration works now in the Baron release of OpenDaylight. So yeah, so these are the the high-level topics I'm going to talk. SFC, which hopefully most of you folks know. Existing SFC support for Mano and OpenStack. I think Brady and Andre touched it a little bit on that. New integration architecture for SFC support, and that is very specific to the OpenStack integration. And then I'll give you a quick demo, given that depends on how much time we have. So. I draw these, very whiteboard kind of boxes here to just, show how things are, and then I'll show you the architecture diagram of it. So SFC, what is SFC? So you have one machine, you are running one VM, another machine, you are running another VM. They are connected to the virtual switches, and this is a simple communication. If you ping from one, VM1 to VM2, they'll just as a direct ping, right? What most of the Mano use cases and NFV use cases are about, steering the traffic through different waypoints, and these waypoints can be your networking services. Okay, so here in case, let's say you want to steer your traffic through the firewall service, and firewall is basically, let's say, it's another VM running the firewall service on some other host. It need not to be same host. It can be anywhere in the network. Okay, so what you really want is the traffic goes from host 1 to host 3 through the firewall, and then it comes back to host 2. Okay, so this is how we want to route the traffic, and this is what in a very layman term, this is what we is the crux of SFC, that you want to route the traffic through different waypoints. And to give it an IETF definition to it, so we call this firewall the VM that is running this network service. We call it service function. The switch, the OVS switch that is connected to this VM is SFF. We call it service function forwarder. And then we have, if you look at the host 1, we have a 1V switch from where the traffic is going to host 3. That is an ingress switch for it. And once the traffic comes out of firewall, it goes to the host 2 switch, and that is an egress switch. So obviously, this whole, arrow is kind of your tunnel for you. Okay, so once you create a tunnel, you need someone to kind of put traffic into it, right? So ingress and egress is basically we put a classification rules there so that they can, put the traffic in the tunnel, and once the traffic comes out of it, reclassify it, or it can send it back to the destination. So this is the high-level idea about how generally SFC is done, or it's like it's been done in a way, but now with all the virtualization of your networking services, it becomes more critical because now you have to do everything programmatically, right? So that's where this problem get complex. As Brady was explaining all those things, up to a certain level, it's okay to understand it, but when you go deep down, it gets complex. Now that was the IETF definition, but when we talk about ETSI standards, they talk about in different terminology. So your firewall here they call it VNF. Then the switch, they call it virtual link. And rest all classification is pretty much same, but the service chain, they call it VNF forwarding graph. I'm not saying they are kind of same. I'm just saying this is the terminology they are using. They have a different use cases, and that's how they define the different kind of specs around there. And when you go into detail, you see the differences, what actually the use case ETSI is trying to handle and what IETF trying to handle. And the good and a bad thing is when it comes to OpenStack and OpenDaylight integration, they both come into the picture. Okay, so that's where we are going to talk a little bit more in that detail. And in this chain, it's a very simplistic chain, right? So but it does not really mean, it can allow you a lot of other stuff. So service chaining can allow you having a multiple VNFs. Okay, those VNFs can be across any number of compute hosts. They can be on the same compute host also, right? And one VNF can be used in multiple chains, and multiple kind of classifier you can write for a single chain. So there's a lot of combinations and permutations are there in this one. So as of now, the use cases we are trying to handle is very simplistic use cases that we have in SFC from OpenStack perspective, because ODL SFC, I think it supports more complex use cases for it, like you can use abstract VNF type and all that. But as of now, from OpenStack perspective, it's very simple, chaining mechanisms where you have multiple VNF in one chain and you configure it. So as I mentioned, there are three major components here. One is a classification that steers your traffic to the tunnel, which is basically your chain. And the second part is the chain itself. And the third part is service function forwarder, which is the switch that is connected to your VNF. So any question till now? I think it's very simple. The idea is how these things work. It's just a steering of traffic. So now if you see at this diagram, right? So now let's see what happens. So here we have a VMs, and then we have a virtual switches. So we need someone to kind of create those VMs, and we need someone to handle our networking. So they're going to handle our virtual switches to kind of establish this routing part of it, right? So there are two different components, and we need two different entities who can handle these things. They can be in the same component or they can be different, right? So you need a virtual networking provider to handle the networking, and VIM, virtual infrastructure manager, who kind of spawns VM and VNF for you and all that. Now, next thing is, okay, these two are managing two different things, but you need an orchestrator on top of it where you can design your solution. You need a chain, but Vim is not going to tell you what kind of chain you want to create. The chain is a one-layer higher abstraction. It goes above the networking solution and the Vim part of it. So you have an orchestrator there. So I mentioned it's a VNF manager, which actually manages the life cycle of these VMs that you spawn, and NFVO, this orchestrator that actually create the chaining and all that at the orchestrator level of it. So this is the third component in the picture. So now what it does, is if you look at this thing, VNF basically asks virtual manager here to create a VM, and it actually spawns your VNF. You can spawn VNF and VM both through the Vim. But VNF management is done by VNF manager and is sitting on top of it. So I'll see which VNF manager we are using actually. So, and the second thing that VNF manager, or NFVO, basically does it creates a VNF forwarding graph for you. Okay, so it will ask networking provider to say and go and say, okay, create this forwarding graph for me. Okay. And this goes and configure all the switches and install all the proper rules to kind of establish the chain. And then it will eventually enable your chain here. Okay, so this is how both the component works, how the high-level orchestrator is consuming the Vim part of it and the networking provider part of it. So now let's set the context here. So this VNF and NFVO here is in our picture is basically Tacker, but it's not very specific to it because Tacker now is consuming the standard interfaces. So any of the orchestrator can, if they are using these standard interfaces, they can, be replaced by Tacker. You can plug in that orchestrator and you can use it. Vim is, in our picture, is OpenStack, but you can have other Vims also, but that support is still not in picture. But yeah, Vim is, in our case, OpenStack is the Vim we are using, and OpenDaylight is a networking provider we are using. And so this is ETSI manner definition I told you, right? So they call it VNF forwarding graph, and what they assume. So graph can be realized as a multiple, service, function chain and classifier compiled to form a graph. So one VNF forwarding graph can have a multiple chains and multiple classifiers. Okay, so this is the broader definition of VNF forwarding graph. But in case in our demo or in the work we are doing is pretty much you can map it VNF forwarding graph to the SFC chain. So it's pretty much, same. But VNF forwarding graph in this context is giving a higher level abstraction here. When it comes down to the networking provider, is basically the real chain. It says which VM you want to kind of hook to this particular chain and what are the specific classifier where you have to install and all that. So that details go to the networking provider and it actually configures it. And yeah, at CMNO, they are, Tacker mostly use Tacker template, Tosca templates, and we define all the, YAML templates for VNF, VNFD, VNF, FFGD. So it's all the resource that you want to create, you create through a Tosca templates, and that is, something you have to define in YAML templates. So I won't go into detail much of these things because, you go details, you kind of lost the track of it. So I just wanted to keep it at a high level. That was the one. So if you want to, you can create multiple service chain also that goes through a different VNFs, and and one VNF can be part of two chain, if you can see here. So it actually shows the another example where how you can go for advanced use cases for the service function chaining. So now what we have currently, I think Andre and Brady was talking about. That integration as of now is this. Okay, so you have a Tacker that talks to OpenStack and it creates a VNF and VM for you. So it spawns all the VNFs. So if Tacker will go to OpenStack and say create a service function for me and the type is firewall. So that is one thing. And now you have to create the chaining for you. So for the chaining purpose, Tacker directly go to ODL. It calls its Yang models that is exposed by a SFC. And it actually, instruct OpenDaylight to create a service function chaining. Do we have a pointer here? No. Oh, it's not working, right?
No, it doesn't work on that white.
Okay, it's okay. So Tacker will, send a request to MD-cell data store, which is listened by SFC, and SFC eventually will create a chain for you. And then it will write a flow classifier also. That flow classifier will go to Netvirt project. Here, for example, I'm using Netvirt, but it can be any classifier for that matter. GBP also can be used here. And the flow classifier request goes to the Netvirt, and then Netvirt basically put in, classifier rules on the switches. Okay, so this is how the current integration is. So Tacker is the main component. You talk to these different, component. One is OpenStack and one is ODL. So it sits kind of on top of it. Now, what happens, why we want to change this thing? So there's new change happen, and that change is that OpenStack now expose networking SFC APIs. So they have their own SFC APIs that they expose, I think in the last 1 or 2 release. So now we have a SFC component within OpenStack. And Tacker is also kind of moved to OpenStack as their NFV Mano project. So it gives you to address some of the NFV use cases. So Tacker is also part of these things. So now, given that OpenStack already have networking SFC and Tacker is also part of it. So, and from Netvirt perspective, because networking SFC is part of OpenStack, so we decided to support this because we support most of the services from OpenStack and Netvirt. So we decided to add a support for networking SFC, which is an OpenStack part of it. But yeah, and then it's a quick glimpse of how the networking SFC APIs are defined. So if you look at OpenDaylight or the Mano, ETSI, specs, they have a different terminology, VNF and SFC, they define these things in a different way. But when it comes to OpenStack, it's very, very low-level APIs that they define. They all talk about in terms of ports. Okay, so if you look at these are the APIs that networking SFC project expose. So first is port pair create. Port pair is basically the VM's ingress and egress port. Then you have a port pair group. Group is basically the group of VNF of the equivalent functionality. So it's like you can bunch all of those VM together and you can represent it as a group. Then flow classifier is classifying the traffic, so it's a classifier part of it. Then you have a port chain create. So if you look at the port chain create, it just have an input as a port pair group and a flow classifier. So you just specify the classifier and you just say, okay, these are my port pair groups. You can provide multiple port pair group and it will create a chain across it. So that's how these APIs, at least the version 1 is implemented. So now, given that we have a networking SFC component in the OpenStack, now what we are trying to do is, now Tacker, rather than directly going to OpenDaylight, is going to call networking SFC API. Okay, so the driver is modified, and Tim is sitting here. Tim is working on that part where he's specifying the OPNFV driver for attacker. That is specify the abstract driver for attacker, and the front-facing interface for the NFVO extension of forwarding graph. And attacker now sent this call to networking SFC. So for that also you need a driver. So we are kind of writing a driver in a networking SFC for attacker. And that driver will send a request to networking SFC. Once it's come to networking SFC, the next request goes to networking ODL. But how it goes through is go through a networking ODL, because networking ODL is our front-facing from OpenStack side for OpenDaylight. So the request from networking SFC goes to networking ODL. So we wrote a driver in networking ODL project that actually get all these requests from networking SFC and just pass through it to the networking, to the OpenDaylight. Once the requests come to OpenDaylight, we have a handcrafted REST APIs which we use. We don't really use a Yang or a REST conf model here, because that's how the Neutron northbound project in the OpenDaylight side work. So we have a handcrafted REST APIs, which is basically one-to-one mapping you can do with networking SFC and the Neutron northbound REST APIs. So it's just a pass-through. We get a call from networking SFC and just pass it to OpenDaylight. So now this is how it works. So networking SFC, the call goes to REST API, so Neutron northbound get this request, and then it actually convert them to Neutron Yang models. So internally for each of these REST APIs, the handcrafted REST APIs that we implement, we need to implement a model for that so that we can persist that data into data store. So we wrote a model for that. So whenever the REST requests come, we convert into it and we write into Neutron Yang models, and we write into a data store. Once that data is written, we have a translation layer. The translation layer actually listens on those Neutron Yang model, and those Neutron Yang model is related to SFC and flow classifier. It listens on it. It actually convert the those Neutron Yang models data, and it convert into the flow classifier and the SFC Yang model that is exposed by SFC project and the Netvirt project. So there is a two level of a translation happening here. The first is just REST API to a Neutron Yang model, and then Neutron Yang model to ODL SFC Yang model translation. And this is all happening in OpenDaylight, before things go to SFC. So if you see the difference here, so difference here is like the data is, the call directly go to MD cell and then go to SFC. Right? To give it a formal integration, the way OpenDaylight works with the OpenStack, the things change in this way. So still the call go to MD cell, the same request, same data, but it goes through the formal integration exercise like networking SFC, networking ODL, the Neutron northbound, and this is how the formal integration in OpenDaylight work for other services as well. Yeah.
How complicated is that translation from the networking SFC API to the standardized SFC data?
So as of now, we are getting 2 and 3 information that we are not getting. That is something we already proposed to networking SFC folks. So one is asymmetric. So asymmetric is something they need to pass to us. Second thing is, as of now, because OpenDaylight, attacker don't expect SFC to do the abstract VNF selection and all that. It actually pass you literally SFP, right? So we needed a type, but we don't, for our use case, we don't need a type. So as of now, its translation is there's no complexity. We pretty much get all the data, using it. So yeah, when the translation is pretty simple, the code translation is pretty simple. It's just that, for these data, we have to create a lot of objects in the SFC size, SF, SFF, SFC, SFP, RSP, so, but we have all the data which we need. So I'll show you that thing. So its translation is not complex, and there's some data, for advanced use cases, definitely we'll be missing some data. And that is something we need to talk to networking SFC, and I was talking to Stephen also about these things. So when we go to support advanced use cases, we definitely will need more data from there. Because they have a mechanism, but it's not a standard mechanism, right? You can pass the data using the parameters to the ODL, but those are not a standard way the OpenStack do it, but yeah.
Considering that the OpenDaylight SFC data model is an IETF standardized data model, and the networking SFC is not, it's something they just came up with. Are there plans for networking SFC to standardize?
So there was a discussion that started, but they are not outrightly denying it. But what they're saying is that they don't really have, OpenStack world, they don't really care about IETF much. If you look at most of the APIs they have, right, they are all handcrafted, very specific APIs that is designed by OpenStack. But the use cases that is we propose to networking SFE, I think someone from Intel, Igor from Intel, he proposed these changes. And there are some valid points there. As of now, there's not much progress into it, but everybody at least concluded that we need to, refine the networking SFC API and come up with V2 version if we really want to support some advanced, use cases, like the classification for the VNF itself, right? We don't have it. Networking SFC can't do it as of now. So, and the other thing is passing these argument using a chain parameters and all that. You can do it always. It's like a hacky approach, right? So that's something they are thinking of. So there are 3 and 4 points that came out of the discussion, and I think that's something they are going to work in this or next release.
What's the advantage? Because I mean, this was what you have working there, working before networking SFC. What's the advantage of putting networking SFC in?
Because, yeah, it's like direct call, right? So you call it from Taker directly to the OpenDaylight. Now, given that Taker is a part of the, OpenStack, right? So OpenStack already have their own interfaces. So they expect that all the project that is within the OpenStack umbrella, they should use the existing interface that OpenStack basically supports. So networking SFC is their interface for all the Mano and use cases. So that's the reason they asked Taker project to kind of move to that, use these interfaces, because these interfaces are something which we are kind of exposing it. Other concern for them was if you write all these Mano component within an OpenStack and they start going and talking to different kind of SFC provider and all those things, there's no standard way to kind of keep them together, right? So they wanted to have some standard approach. Now that is, I think is, in my opinion, is a good idea, but the point is whether the interface they provided, that is good enough to kind of cover all the use cases or not, that is still an open question. And I think that is something which they are working out as of now. And I'm hoping that V2 is going to be, it's not going to be very equal to what we have in IETF SFC, but I think it's going to, it will have enough, models that actually can, cover all the use cases that we have. Now the point is whether we need a translation layer there or not. Well, translation is, if it's not an exact copy, you need a translation. Whether you do the, heavy translation or low translation, you need a translation layer there anyways. So I think version 2 of the networking SFC will give, more features and more APIs that we can use for, sophisticated use case also. But as of now, it's very V1 version, so Andrew. So this work is on old network. So next part, I think Andrew was talking about when we kind of do the whole integration of the Genius, SFC, and a network, then this functionality we are planning to move it to the new network. Yeah, just give me a second.
Something that's not quite clear to me is, are you able to take the current networking SFC API and translate it into the NSH-based
Yes.
API that
Yes.
SFC understands?
Yeah.
Okay.
Yeah.
So you're basically creating the information for the NSH header.
Yeah. So from translation perspective, we don't have to, right? We have to say NSH aware, that is something which we need to get, right? So NSH aware is by default, we are setting it to true now, okay? But this is something that should come from the SFC, and that is what SFC folks also is kind of their to-do list. Pass is symmetric, NSH aware, all this data through SFC to the drivers. So this is what they are planning. So this is the information that we need. As of now, we set it symmetric is kind of set to false, and NSH aware is kind of set to true in this translation.
But
Yeah.
the whole thing with the neutral API today is like the VNF is not NSH aware, nothing to be. Current VNF, there is no current VNF that is NSH aware. So do you enforce NSH in this solution or not?
So this is, as of now, is kind of the solution we have in this is enforced. But if the networking SFC pass it like false, it will override it. So by default is passed, but if the networking SFC pass, the code is written in a way that it will kind of override the value. So if the networking SFC pass NSH aware false, it will take it false. But this translation layer don't do that. This comes to the when we pass this data to SFC, and whether the VNF is NSH aware or not, that I think you need to know prior to creating a chain, right? So if you're creating a chain without VNF without SFC aware, I think you need to create a chain with NSH-aware faults, right? Do we support NSH-aware faults in the SFC, Brandy?
I mean, you have the NSH proxy.
You have to use NSH proxy, right? Yeah.
That's the point of it.
Yeah.
That's not saying you don't need the proxy.
Yeah, so you need a proxy to kind of do this.
So today in my OpenStack, I have NSH awareness at all, and none of my DNF, for example. Do I still need to carry NSH headers between the location, even though I'm not using at all NSH?
Yeah, well,
I believe the answer is yes. And also, I mean, the most common use case today, like you said, DNFs don't exist that do support NSH unless your goal is to develop DNFs that support NSH. Then you need all this machinery underlying to develop those features.
so for any SFC, if you want to do the SFC in a proper way, you need NSH for that, right? Now it's very starting time of it, and we don't really have a VNF that actually support the NSH, right? So if they support it, the whole mechanism is in place, right? But if that is not there, then you have to use the NSH proxy for that purpose, right? So because you need support from both the side. If your VNF is not supporting it and you don't want to use a proxy, then we don't really have alternative for that, right?
Yeah, because one of the reasons we created the SFC inside OpenStack is just because of the fact that it's simple and it's not needed the NSH, and the VNF today are not needed. So it's there's not too many complexity of service changes. And it's quite simple. The fact that we're putting in an overhead, and we're not overhead constant, but it's just on the model itself of forwarding inside the data, the overflow rules, or whether that's going under the wire itself also.
Because if you put in that simplicity, now you have to classify it as top. That's not very efficient. That's the difference.
Why?
That's off topic, but if you don't use NSH, you have to classify it every hop.
But anyway, my VNF is not NSH. There is no
You
NSH.
can put an NSH proxy.
Right?
You can put an NSH proxy.
So you put NSH proxy before and after every hop, and we're doing big
So
stuff
you
in
put an
between.
NSH proxy for each service function.
Yeah.
And we can take this offline, but
Yeah.
if you don't use NSH, you have to classify it every hop. It doesn't scale. If you have a million, if you look at this in a mobile phone operator network, you have a million subscribers. You have to classify every hop. That doesn't scale.
It is because we can take it offline. We need a subscriber or something.
Yeah, even that fact, NSH proxy probably is not scalable also, even if you use, right? So, yeah, we are looking for the ideal world, but I think we are not yet there. We need to use hacks, and when you use hacks, there is always a pros and cons for these things, right? So, yeah, I think the ideal world is you have VNFs, which is NSH aware, and that's the ideal world. But still, we don't have it, so we use different approaches for that. And some of them is scalable, some of them is not, right? Okay, so this is how the mapping generally happens. So we get port pair and a port pair group, and we use these details to kind of generate SF and SFF. And then we get a port pair chain, and port pair chain will then generate SFC, SFP, and RSP. And then flow classifier data is converted to ASCL. So this is pretty much the simple mapping. I don't really want to go into detail of how the one member to another member mapping is, but the high level is this is how we map it. So OPN, I think Brady was talking about this, and he mentioned Tim is working on this. And this is the OPNFV. I think this is what we, in a Colorado release we are shipping. So we use OVS 2.5.90. That is a patch from Yi Yang from Intel that actually make the OVS NSH aware. Then we use OpenDaylight Boron, OpenStack Mitaka, and the Tacker project. But this, what it ships is basically the first approach where Tacker directly talk to OpenDaylight. So it's what work we are doing is still not in OPNFV. This is not shipped. So this all shipping is as of now is done using the old approach. So this is, more formal diagram with all the components that are involved in the whole SFC chain. So you have a attacker, you have a heat nova to kind of spawn your VNFs, and then you have ODL controller, and we have a 2 driver as of now in attacker. One is SFC driver and Netvirt SFC driver. SFC driver talk to SFC directory, and Netvirt SFC driver that basically send a classify request. So this is the old model, and this is what we ship as of now in Colorado. And this is what we are thinking of, how the new architecture will look like. So it's this same thing which I explained you just now. So this is the formal integration, how we are doing. So all the boxes which we shown that we need to write is all done. So OpenDaylight side, everything is kind of committed as part of the Boron release. OpenStack side, we are writing this SFC. OpenStack side, basically there are 3 components. One is for attacker, there need to be a VNF forwarding graph driver that is already committed. So Tim did that work and is already in part of the attacker now. Then there is a second piece that is converting attacker VNF forwarding graph calls to networking SFC. That is done by Stephen Wong. He's, I think, with Intel. So he also pushed that patch, and I think that is also merged. The third piece is the networking ODL driver. So we already have a version 1 driver that we pushed, but networking ODL need a version 2 driver, so that is something which we are working on. Apart from there, all the boxes in this diagram is kind of done. So all the yellow boxes there is done. So ODL SFC driver, which version 1 is there, but version 2 is something which we are working on now. Okay. So these are the references, So first is ETSI Mano spec about the VNF forwarding graph, ETSI SFC model that Brady was talking about, and the Yang model that we use in OpenDaylight SFC. VNF FG spec for attacker that Tim pushed it. So all the details of how that driver is written and what all is the APIs that it exposed, you can find those details there. Then the code which Tim pushed is also there. You can look at this Garrett. Then we have SFC driver spec that is Stephen Wong pushed to get a detail how the conversion from VNF forwarding graph to SFC happen. You can get details there. And the code also you can see on this Garrett. OPNFV SFC project, which Tim is kind of working on that, and he, the whole service function chaining is that work is happening where we package the whole integration exercise there, and I think Brady is leading that. Brady is a PTL of that, so and Brady is PTL of OpenDaylight SFC project. So if you have anything SFC related, catch him. So he can help you with OPNFV and this, and probably with OpenDaylight also. So yeah, so SFC models, you can look at these links, and then we have SFC projects, so it has quite a good documentation, so you can look at that also, and it has a nice script for demo and all those things which you can use. Networking SFC, these are the APIs. And rest all is the related to OpenDaylight work that we pushed, northbound model changes, REST APIs, and classifier code and translation layer. All these detail, you can get it here. If you're planning to use it, I would suggest you have to use the Yang's NSH patch. You can get it from here. It has a good, script that you can use and, just modify your OVS to kind of support NSH. Okay, so any question? Or let's go to demo then. So in my demo, I have very simple topology. You have HTTP client, you have HTTP server that is running HTTP server, and then you have VNF firewall in between. So I'm going to show is, HTTP client is trying to reach out to HTTP server. It will get a response. Then we create a chain where we say this HTTP request should go through the VNF, and then it should go to the server. That's the part I'm going to show. So let's first try to ping it directly. So this is my HTTP client. So I send this request, I get a response, and this is my HTTP server. Yeah. So let's try it once more. And you get this request here. It's visible, right? Oh, yeah. And then we have this VNF firewall, which basically are running a tool. And this tool, basically, whatever the packet comes, it actually forward out on the egress port. Okay. So now what we are going to do is we're going to create a chain, and then we are going to send the same request. So packet should go through this VNF here. So to create a chain, these are the 4 commands that we need to run. Do you see it? Okay, so first one is creating a port pair, and it takes a tenant ID, then it takes an ingress port and an egress port. Basically, when your VM has only one interface, these ingress and egress port are going to be same. So let's create that. Okay. So it creates a VNF first for you. So when VNF this call happens, it just store the data into the data store. Translation layer don't do much here. It's just the getting a data. The main translation and the creation of SF and SFF happens when the chain is basically created here. So now it's time to create a port group. So I'm creating a port group here, which basically says use this particular port pair, and the name of this VNF is firewall. So we create that. Now it's time to create a classifier. So it creates a classifier. It says any traffic that is coming from port 20 and going to port 80, it should go to the through the chain. And now it's time to create a chain. And finger crossed, it should work. So let's send the request again. So I send the request, and if you see here in this VNF, right, all the traffic is going through this. So all the packet started showing up here. Let's send the request again and see. And then you see again. So, and it goes to the final server and get a response back, and you see here. So previously this traffic was directly going through, and now once we created a chain, the traffic is going through the chain now. Yeah, that's pretty much my demo. So I'm open for questions if you have, and Brady would also like to join me to answer a few of the questions. So. Oh man. Okay, so I'm done with the session. So any questions, please? Yep. Yeah, it's strange. The problem is now if we want these two worlds to talk, directly when we were talking, even when the previous approach we showed, when Tracker directly talked to the OpenDaylight, there was a translation happening already, right? The translation was done by a Tracker driver, okay? So you need the translation anyway. Now the point is, now with this approach we have a two translation. Now the problem is when you do a two level of a translation, there is always a problem of loss in a translation, right? So you miss some of the data that don't go to the end of the lower layer networking provider. Now the argument against that is the use cases that these orchestrator was trying to do is that all the SFC related all the abstraction, all the complexity with the use cases, sophisticated SFC, that is something which be taken care of at the level of orchestrator. Okay, the thing they will pass down to the provider is very concrete path. It's like RSPs basically they are going to pass, and this is something that they want, right? To creating a RSP, how much of a details that you need, it depends on that. So that is what you have to translate from there, right? But obviously, because the two level of translation, there is always a issue of where is what if some things not translate. That's where the problem is. But it's one level translation is still we have to do. But that's how the integration approach here is.
One level definitely from ETSI to IETF. But I mean, what I see is that especially when talking about Neutron's API, it doesn't have. It's not so powerful as IETF or ETSI. So I do agree with you that it would be good to have a version 2 inside a Neutron networking SFC. I don't know, maybe it would be good that we from SFC could also, IODL SFC could also participate in those discussions so that we can enhance somehow this API. So far,
I think that's already going on, right? That discussion is already going on. I'm not sure how actively it is because the patch that Igor pushed, it has a detail, it has a good discussion on that. What is already there, what we should improve, why we should improve, and all the reasoning. And there was some good point I mentioned earlier, right? So that discussion is there, but I'm not sure how actively, both of the parties are pursuing as of now. But the understanding I got is that networking SFC folks are open to kind of refine their APIs to make it more powerful. But yeah, we need to give them a feedback what is actually. So this is the first exercise which we are doing, So kind of use cases as of now we are trying, we are missing, 3 and 4 details. That is what we are asking them to kind of, provide a, standard mechanism that we can get it. Now the more use cases comes, it's an iterative process, right? So they have to refine their APIs. Now whether they will move to IETF standard or not, I'm not sure because none of them actually, at least networking SFC project, they didn't find any strong, use case to kind of literally go to IETF way or something.
You can at least go ETSI.
Yeah.
At least, it's, okay, I already said.
No, but the point is, if it goes to ETSI, if you look at this, it's like, they go to ETSI, that's a good thing, if they do it. But even the terminology is totally different. So it's like if you want somebody to understand the whole thing, you understand ETSI, you understand the, IETF, but then you have your own half-cooked, stuff in between. So approach-wise, I personally think is, having a simpler API is okay. But whether they address all of your use cases or not, that's a different story. So I'm personally fine if they don't move to ETSI or IETF, but I want those API to be strong enough that it support the use cases of both of these things, right? Because translation is something which you can't avoid anyway. If you want two systems to integrate and work together, you need a translation. Whether it's going to be minor or a major, that's where the main thing is. So if they can make it in a way so that we have to do less translation, that is better, right? So that's what I'm thinking of, if they are heading in that direction. This is what the impression I got. So they are open to kind of, any feedback, and they are open to discussion to change the API and all that thing. But yeah, they're not going to buy, I think, the IETF, argument that, either you move to this or that. Because OpenStack overall, if you look at all the APIs, they are all, handmade, handcrafted APIs. Yeah, so yeah. Thanks everyone. Thanks for joining me. There so that they can put the traffic in the tunnel, and once the traffic comes out of it, reclassify it, or it can send it back to the destination. So this is a high level idea about how generally SFC is done, or it's like it's been done in a way, but now with all the virtualization and virtualization of your networking services, it become more critical because now you have to do everything programmatically, right? So that's where this problem get complex, as Brady was explaining all those things, up to a certain level, it's okay to understand it, but when you go deep down, it gets complex. Now, that was IETF definition, but when we talk about ETSI standards, they talk about in different terminology. So your firewall here is, they call it VNF. Then the switch, they call it virtual link. And rest all classification is pretty much same, but the service chain, they call it VNF forwarding graph. I'm not saying they are kind of same. I'm just saying, this is the terminology they are using. They have a different use cases, and that's how they define the different kind of specs around there. And when you go into detail, you'll see the differences, what actually the use case, ETSI is trying to handle and what IETF trying to handle. And the good and a bad thing is when it comes to OpenStack and OpenDaylight integration, they both come into the picture. Okay, so that's where we are going to talk a little bit more in the detail. And in this chain, it's a very simplistic chain, right? So, but it does not really mean it can allow you a lot of other stuff. So service chaining can allow you having a multiple VNFs. Okay, those VNFs can be across any number of compute hosts. They can be on the same compute host also, right? And one VNF can be used in multiple chains, and multiple kind of classifier you can write for a single chain. So there's a lot of combinations and permutations are there in this one. So as of now, the use cases we are trying to handle is very simplistic use cases that we have in SFC from OpenStack perspective, because ODL SFC, I think it supports more complex use cases for it, like you can use abstract VNF type and all that. But as of now, from OpenStack perspective, it's very simple, chaining mechanisms where you have multiple VNF in one chain and you configure it. So as I mentioned, there are three existing SFC support for Mano and OpenStack. I think Brady and Andre touched it a little bit on that. new integration architecture for SFC support, and that is very specific to the OpenStack integration. And then I'll give you a quick demo, given that depends on how much time we have. So I draw these very whiteboard kind of boxes here to just show how things are, and then I'll show you the architecture diagram of it. So SFC, what is SFC? So you have one machine, you are running one VM, another machine, you are running another VM. They are connected to the virtual switches, and this is a simple communication. If you ping from VM1 to VM2, they'll just as a direct ping, right? What most of the Mano use cases and NFV use cases are about, steering the traffic through different waypoints, and these waypoints can be your networking services. Okay, so here in case, let's say you want to, steer your traffic through the firewall service, and firewall is basically, let's say, it's another, VM running. So today I'm going to talk about the OpenStack and OpenDaylight integration, specifically for the service function chaining. I think the session that Andre and Brady was giving, they were talking a lot about the detail of that part and how we are doing it and how we are solving these complex problems from the ODL side of it. Now, what I'm going to show you guys is like when you talk about these big words, OpenStack, OpenDaylight, and SFC, these are pretty complex systems. Okay, and anything you want to talk within 25 minutes is a bit of risky job. So I try to explain this as simple as possible. What I wanted to you to take away from this session is what work was already there and where we are heading towards and what kind of work we already did. So and at the end of the session, I'll show you a demo which actually the current work which we are doing and which we did. I think I'll show you that demo, that how we are actually making the whole integration works now in the Baron release of OpenDaylight. So yeah, so these are the high-level topics I'm going to talk. SFC, which hopefully most of you folks know, the firewall service on some other host. It need not to be same host. It can be anywhere in the network. Okay, so what you really want is the traffic goes from host 1 to host 3 through the firewall, and then it comes back to host 2. Okay, so this is how we want to route the traffic, and this is what, in a very layman term, this is what we, is the crux of SFC, that you want to, route the traffic through different waypoints. And to give it an IETF definition to it, so we call this firewall, the VM that is running this network service, we call it service function. The switch, the OVS switch that is connected to this VM is SFF, we call it service function forwarder. And then we have, if you look at the host 1, we have a 1V switch from where the traffic is going to host 3. That is an ingress switch for it. And once the traffic comes out of firewall, it goes to the host 2 switch, and that is an egress switch. So obviously, this whole, arrow is kind of your tunnel for you. Okay, so once you create a tunnel, you need someone to kind of put traffic into it, right? So ingress and egress is basically we put a classification rules